Imagine our everyday world as just a glimpse, a shadow of a far richer reality unfolding in dimensions beyond what we normally see. In this exploration, we're diving into the idea that our three-dimensional experience might actually be the visible projection of a hidden, higher-dimensional computation. Think of it as uncovering the secret behind a cosmic movie projection, where the real story is created in an unseen four-dimensional studio. We'll start by gently unraveling how mathematics gives us the language to describe extra dimensions using concepts like vector spaces and matrices, and how these tools help us picture the celestial choreography of the universe. Next, we take a friendly stroll through astrophysics, learning how mysterious phenomena like black holes and quantum superposition hint that information and computation might be the very backbone of everything around us. Finally, we'll explore deep questions about what it means to be truly real and how our own consciousness might be an active participant in this grand cosmic algorithm. This journey bridges solid ideas with imaginative storytelling, inviting all curious minds to reconsider what reality really is, all explained in clear, relatable language without overwhelming technical jargon. At the heart of our exploration lies mathematics, which serves as a precise language to describe the hidden fabric of the cosmos. Picture a celestial loom, a magical device spinning threads of raw data in a realm beyond our ordinary three dimensions. In simple terms, a dimension is any independent direction in which you can move. A line has one dimension, a plane has two, and our familiar world is made of three. But what happens when we add a fourth spatial coordinate? Here, our conventional view expands to become an intricate projection of higher dimensional actions. Using the building blocks of math, such as vector spaces and matrices, we can represent points in three-dimensional space with coordinates x, y, z, and similarly extend these ideas to four dimensions by adding a w coordinate. Matrices help us rotate, translate, and reflect objects whether they exist in three dimensions or extend into four. Even if our eyes cannot directly see a 4D object, the mathematics allows us to explore its properties in a tangible way. Another powerful tool is tensor calculus, a generalization that captures complex relationships between different dimensions. Think of tensors as the next evolution in the language of geometry. They let us write down precise rules that remain true regardless of the dimensional space involved. This mathematical clarity enables us to reason about higher dimensional processes with the same ease as we handle everyday shapes and motions. All these ideas together build a framework that not only illustrates but also validates the notion that our three-dimensional reality is merely a beautifully rendered shadow cast by deeper computational processes in higher dimensions. Venturing from the realm of abstract mathematics, physics provides us with striking examples of how our universe might operate as a grand computation. One of the most fascinating phenomena in this context is the black hole. While many think of black holes as cosmic vacuum cleaners, modern insights reveal them to be extraordinary archives of cosmic data. The boundary of a black hole, known as the event horizon, acts like a vault where every interaction is recorded. Some scientists propose that all the information from anything swallowed by a black hole is etched onto its surface, similar to how a hologram encodes a three-dimensional image on a two-dimensional plate. Another key ingredient in our cosmic recipe is Hawking radiation, faint energy leaks that black holes emit because of quantum effects near the event horizon. This radiation can be imagined as the gradual release of stored cosmic information throughout time, hinting at the idea that nothing in the universe is ever truly lost. Such insights reinforce the concept that, at its core, the universe may be more like a dynamic computer that stores and processes information in higher dimensions. Quantum mechanics further deepens the intrigue. In the quantum world, particles don't reside in fixed states. They exist in superpositions, a blend of possibilities until an observation collapses them into reality. Add to that the curious phenomenon of entanglement, where two particles remain mysteriously connected regardless of the distance between them, and it becomes clear that the very fabric of matter might be woven from informational threads that extend beyond the standard three dimensions. These physical principles suggest that our observed world, the stars, galaxies, and even the very atoms that make us up, may result from complex, higher-dimensional computations that operate at both the largest and smallest scales. What does it really mean for something to be real? When we consider that our tangible world might simply be a projection of a deeper computational process, we are invited to rethink our entire understanding of existence. This idea echoes the ancient allegory of the cave, where prisoners see shadows on a wall and mistake them for reality. Similarly, the objects we interact with on a daily basis might be just distilled impressions of a richer underlying truth. In this view, our consciousness isn't a passive observer, but an active agent in the cosmic computation. Imagine your mind as part of a vast network that not only receives data from the universe, but also contributes to shaping it. This perspective invites us to see our thoughts and perceptions as integral inputs, data points that, when processed alongside cosmic calculations, help sculpt the tapestry of what we call reality. The famous observer effect in quantum mechanics reinforces this idea by showing that the act of observation can alter the state of a system. In other words, when you observe something, you don't just record its state, you participate in defining it. Beyond these scientific musings lie deeply personal questions. If everything we see is an emergent phenomenon, created by an underlying informational flow, then what is the true nature of existence? Is it defined solely by material interactions, or is there a subtle sacred structure beneath that gives rise to both matter and meaning? These reflections encourage us to embrace a more holistic view of life, one that recognizes both the measurable and the mysterious aspects of our universe. Imagine a lone traveler navigating the endless universe, a curious explorer known as the wandering chrononaut. Armed with an ancient artifact, a prism of infinite possibility, the chrononaut embarks on a journey where science meets poetic wonder. As they drift among the quiet expanses of space, they notice that familiar constellations and galaxies start shifting in unexpected ways. In some moments, clusters of starlight flicker as if rearranged by a hidden hand, and in others, entire galaxies dissolve into streams of luminous code before reassembling with breathtaking precision. This mesmerizing experience reveals to the chrononaut that the universe is not a fixed expanse of inert matter, but a vibrant tapestry spun by higher dimensional computations. The prism acts like a window into the underlying process, showing fleeting images of cosmic threads intricately interwoven into the fabric of reality. Each twist and turn of these threads suggests that what we observe as chance or chaos is actually part of a grand, deliberate algorithm. Furthermore, as the chrononaut watches these celestial patterns evolve, a profound realization dawns. The role of the observer is far from passive. The very act of watching these phenomena seems to interact with and subtly influence the dance of cosmic data. This merging of observation and computation hints at an extraordinary partnership between the cosmos and its conscious inhabitants. In witnessing the interplay of light, shadow, and algorithm, the chrononaut experiences not just the awe of discovery, but also a deep sense of connectedness, reminding us that each of us is an active participant in the ever-unfolding narrative of the universe. Bringing together the insights from mathematics, physics, and philosophy, we see that the universe may be best understood as a grand computational system where every particle and thought contributes to a collective, evolving code. This new narrative challenges traditional ideas and invites us to reimagine reality as an emergent phenomenon shaped by deeper informational processes. By exploring how black holes archive cosmic data, how quantum mechanics hints at non-local connections, and how our consciousness might interact with the very fabric of existence, we open doors to innovative research and creative possibilities. Embracing this fusion of science and poetic insight not only broadens our understanding, but also inspires us to become active co-creators in the cosmic picture, blazing new trails in our quest for truth and meaning. In summary, our journey reveals that reality might be a beautifully rendered shadow of a higher dimensional computation, where science, art, and consciousness merge. This perspective encourages us to stay curious, challenge our perceptions, and continue exploring the magnificent tapestry that is our universe.